Hi everyone, this year we've been researching using metal 3D printing to manufacture waveguides and antennas. So what are waveguides and antennas? They're basically a type of electromagnetic transmission line commonly used in radar and in sonar. So how this works is a device called a signal generator can generate some waves, and the waveguide is responsible for transmitting those waves from the generator to an antenna. That antenna will then radiate those waves out into the air for other people to pick up. So this can be used, for example, for communication. And the key characteristics of our project were trying to print for about half the price while maintaining similar electrical performance to traditionally manufactured parts. In particular, it's really important that we keep our surfaces as smooth as possible, as this prevents losses of our signals. And so this quarter, we really focused on manufacturing these waveguides and horn antennas using 3D printing. So the current manufacturing process has some known issues, which is that it uses this process called dip raising, which really struggles with manufacturing more complicated architectures like the one you see here at a cheap price point. So how we started our project was by printing this straight waveguide component that you can see here. And the purpose of this test was just to see if the project is at all feasible, to see if we can get similar electric performance while keeping the price low. And it turns out that you can. The other thing that we researched was using chemical etching. Like we mentioned, the surface roughness directly affects our electrical performance. So we used this process to smooth our parts out after being printed. And you can see that we took our surface roughness from around 140 to about 110 microinches. And in terms of our electrical performance, it went from slightly underperforming the machine parts to slightly overperforming. So here are results for that straight waveguide component after being polished using chemical etching. You can see that across the frequency range here, a better signal is a lower signal. So you can see that we're actually pretty consistently outperforming the machine component here, which is super exciting. We also focused on printing a couple different types of horn antennas, like the ones you see on the screen. And the results here were also very good, but slightly more mixed. You can see across the frequency range that we're slightly overperforming compared to the machine components in some areas and slightly underperforming in others. But we did take these results prior to chemically etching them. So we're hoping that using some kind of polishing process, it's possible that you could more consistently outperform these parts. So as you can see from the results, this process is super interesting and could potentially help replace the inferior chemical or dip raising process in the future. So we had a great time with the project, and thanks for your time.